join. I'm not going to read your bios again because you've all been already introduced, but just as a reminder, so we've got Radim Dondelek, who's Independent Research and Development Officer Engines for Zeto Tractors.
Yes.
We've got David Heaton, Senior Technical Specialist, Caterpillar Innovation and Technology Development Division. Yeah. And we've got Antti Martinen, Manager Product Management, Global Engine Installations for Agco. So thanks for joining. The panel we're going to have now is about solutions in fuel efficient and low emission technologies for no-road mobile machinery. As I start, what I'd like to suggest is we're talking about fuel efficiency tractors, tractors or construction equipment and other type of machinery. Could you quickly just give us an introduction, your initial thoughts, remarks about how important it is to bring fuel efficient machinery equipment to the market? How, when a customer is about to choose which machine he's going to buy, is fuel efficiency an important factor? How does that compare with other criteria like comfort, drivability, and so on? So just your initial thoughts on how important fuel efficient equipment is.
Okay.
Yep.
Well, I can start from my side. So the agriculture industry, it has both sides. So we have small farms, hobby farmers, backyard farmers who really don't care too much about the fuel efficiency. They are all about the cost of the machinery. But then, on the other hand, we have the big market, which is the professional, big farms, corporate farms, especially in Northern America, South America, and Eastern Europe, and also some parts of Southern Europe where we have really huge farms. And in these markets, the fuel efficiency plays a really important role. The fuel cost can go all the way up to 1/3 of the machine operation cost, including the driver and all the other machinery they are using. So fuel efficiency plays a critical role in the professional farming segment.
Shall I? Well, I guess my experience is similar to yours, Matti, but just to bring it home, when I started in diesel engineering, if you had 5% more fuel consumption, you just fitted a 5% bigger tank, which we certainly don't do that anymore now. We are at the stage where we look at all of our technologies and we do cost-benefit analysis for every one, various scenarios. I must admit, your hobby farmer, he has a hard time. Yep. It's very hard to convince a hobby farmer that he needs some high efficiency device on his engine. But as I say, at the higher end, it is very important. What we do also, though, is the big change that I've seen is that we look at our systems on a total system perspective, where our experience is that the engine and the components can maybe give 5 or 10% now from where we were in the future. But the really big gains we can see are in the complete system. So improving transmissions, improving drives, improving ground to machine interaction. And then you have even bigger savings where you really can be looking at halving or even quartering your fuel costs, is where you actually have operator and job site optimization. And I'm thinking there about things like our CAT AccuGrade, which is we often term it's like CNC manufacturing of roads. We have sensors placed along where we want a road, and our grading system will actually move the shovel on the motor grader in order to give you a flat surface once off, so you don't have to go around in an iterative process. So that's really where we see the benefit, and that has become a pretty major theme within Caterpillar over the last 10 years or so. Yep.
I could actually comment on that. So that's also something we are seeing a lot. It's not just the engine, it's a complete system, but it's also not just the system, it's the operator itself, how they operate the machine, And then it's not just the system and the operator, it's also how you manage your complete farm operation, so optimizing the use of the machines. And that's where we also see big benefits, and that's where the future is going more and more, is optimizing the use of the machines. Yeah. And there are a lot of benefits to achieve on that side.
Yeah, I can only second my colleagues. Anyhow, it's easy to answer this question. Any benefit in the fuel consumption is highly appreciated by the customer. According to our experience, the customers do not care about the emission level. They would like to have simple device, simple tractor with very low costs of the service, and the device which could be easy to repair with low cost of spare parts. So any benefit in the fuel consumption is highly appreciated, of course.
Great, great. One thing I'd like to ask, and then also get your thoughts, and then we can open for the audience. Also, if you have questions, you can either raise your hand, or if you're shy, you can send a text message to this number, or get the message here. No one will know who you are. But anyway, first question. If you, so we talk a lot about fuel efficiency and low emissions, and how to achieve, to improve both at the same time. Our experience is that depending on the technology you use, EGR being the most common one for this, if you can reduce emissions but increase your fuel consumption, so the main question I have there is, we're moving from stage 4 to 5 now in a couple of years' time. Stage 5 is focused on emissions, particularly bringing NOx, PM levels to lower levels. How do you see stage 5 bringing any impact, positive or negative, to fuel consumption, and how this is going to, what are we likely to see for the upcoming stage 5 engine equipment?
So if we're looking on what was achieved already in Tier 4 final and stage 4 phases, the engine and the technology, it's already really fuel efficient. With stage 5, combining the DPF and SCR systems, this gives some more room to optimize a little bit more, but from the emission technology point of view, doesn't bring that much of savings in the fuel. So, of course, like I said, for our customer, the cost of ownership is important, and the cost of machinery, so we are looking also in additional things what we can do with the machines to reduce the fuel consumption. But the emission legislation itself doesn't bring much of benefit in that.
Our experience is slightly different, actually. I'd say we've had one constraint removed and we've had another one put on us. The constraint removed that we've had is that we no longer, because we're mandated to fit particulate traps, we are no longer having to run at very high air fuel ratios for low engine out levels of soot, and as a result of that, you can re-optimize to a different position, and in particular, when you're Pmax limited, you can advance your timing because you're not pumping so much air. You don't have the additional pumping losses of turbocharging. So no, it's actually freed us up quite a bit. On the other side, you now have an additional constraint, which is you have to fit a particulate trap, and therefore you do have higher back pressure, which in turn isn't always bad. It can mean you can drive more EGR, which in turn means you can advance timing for the same engine out NOx level. So the net result of this is actually we found that we will be coming out with substantially better fuel consumption at stage 5.
Okay. And what's your experience?
I would fully agree with David. Yeah. I would like to note that this is the real work of the engineers doing the development and the testing, to find the proper balance between the between the engine parameters and the outputs. For example, the fuel consumption, the emission level, and so on. So this is our work to find the proper balance.
It is, and I think what in my experience over years is actually engines have also the trade-offs on engines. They're all very similar now.
Yeah, they are.
They are. I'm sure my trade-offs will match your trade-offs, and vice versa.
Well, that's something that Stage 5 is bringing. It's bringing us all back together on the
It
same.
is.
So at some point in the TF, or Stage 4 and 3B, we went divided paths, but now everybody's getting back together.
Yeah.
And back to your question, when we are comparing our solution, Stage 4 and Stage 5, we do not expect any big difference because, as you see in my presentation, we are using the same structure of the after treatment. So there will be nothing to be added in Stage 5. So when we compare our Stage 4 and Stage 5 solution, we will be at the same level.
Okay.
I'm sure
So
there's going to be further optimization as always.
Of course.
Okay.
Of
So I
course.
guess
But
the
it
main-
needs some time
Yep.
to do the optimization and some experience which we are gaining continually.
So I guess the main impact for Stage 5 is going to be for OEMs, equipment that are not doing SCR now, and that are likely to or SCR and DPF now, and then they're likely to move back to an SCR, to align with other manufacturers on an SCR plus DPF.
The real problem is packaging.
Yeah,
It's
I would.
hard.
Yeah, again, I have to fully agree. The packaging is very crucial, especially when you imagine the space which is available at the tractor. It's a really crucial topic, the packaging. And I would like to say that I see the benefit, for example, in the SCR solution, where we could combine the SCR catalyst and the diesel particulate filter in one package, in one canning. This would really help us a lot.
Well, it helps on some applications, but for some applications it's challenged. So again, there's no one right answer in that either. So that brings the diversity of the off-road industry. It's small volume with high diversity of the machinery.
Yes.
So it's developing a lot of different solutions for small volume is also a challenge.
Yes.
Wait, does anyone have any questions to the panel? There's one here. There's a microphone coming. Yeah. So just state your name and your company, please. And no. We'll get there. Yeah, now there's a green light on it, so maybe. Oh,
Right.
good. Thanks.
I think if we were sitting next door with the heavy duty on road group, obviously heavy duty trucks have a real imperative in terms of fuel consumption. So every point of SFC is really valuable to them. So how do you think the off-highway solutions compare to the Euro 6 truck solutions in terms of their focus on fuel economy?
Okay.
Yes, if we are looking on solution overview, we are fairly comparable where the truck industry is at the moment. Well, trucks, they have also regulations driving on the fuel efficiency. From on-highway perspective, it's more competition-driven, so we always need to be better than the competitor. But from a technology point of view, the technologies are really close to each other.
It's very much comparable.
Yeah.
No question about it.
For me, coming back to my first experiences when I first joined Perkins, and I said, well, you've got a 3 or 5% more bigger fuel consumption here, well, fit a bigger tank. The one they really cared about was heat rejection, where for me, I'd always seen heat rejection is to the off-highway market, what fuel consumption was to the on-highway market. That makes waste heat recovery much harder, because as soon as you capture exhaust heat, for example, to use waste heat recovery, you then have to get rid of it again. And that can involve fans, and that in turn can involve parasitic losses, and the fact that we don't move, and the fact also that we operate in dirty and dusty environments, sometimes they're not the same systems they have to operate in. Yeah?
Okay, and if I can stay on the same topic, we've got 06 for on-road vehicles, and we haven't got a legislation on fuel economy CO2 for trucks in Europe yet. But things might come, particularly now with Vector being approved as a measurement tool for CO2 emissions, and also we've got a CO2 legislation for trucks in North America. So we are finding ways of tracking fuel consumption for trucks and heavy-duty trucks and buses. Do you see, we're not talking yet about CO2 fuel economy limits for non-road mobile machinery in Europe. Do you see that coming? Is there anything already going on? Do you see legislation coming? And if you do see, how would that work? How would we set up a limit that would apply to all different sort of machinery?
My guess is good as anyone else's guess. We don't see it in the foreseeable future. Will it come? Will there be something? Hard to say. And that comes again to the point, how do you measure? How do you set up the limits? What is the cycle for the limits? So there are a lot of questions around that. I would see it's going to be more of competition driven, CO2 reduction and fuel efficiency improvement. But what I've been talking with the legislators, they don't actively talk about it yet for non-road mobile machinery. And I don't know if anybody else has a different view, but I don't really see it in the foreseeable future.
One of the problems I see there is, trucks do a fairly standard piece of work. They move things from A to B, and therefore they can be legislated using the vector tool, they can be legislated on grams per kilometre basis. I think we're losing this. Are we there? You can't have, for example, in the agricultural world, could you have a standard field that is ploughed? It depends upon the circumstance. Could you have on the construction side a standard hole that needs to be dug? So actually, to tie that down,
how you measure it, it's going to be interesting.
Yeah. So it may happen. We have. The industry has never said we don't want any further legislation. We've always actually taken legislation and done it appropriately and actually done it very well. The one thing we always say is we like legislation provided it is for a justifiable environmental cause. And also, the most important thing for us is that we have a level playing field, i.e., legislation should not be brought in which gives one manufacturer advantage over another. The third thing we've always said is we'd like the legislation to be harmonised, though I'm not sure we quite got that during all the various tiers 1 to 5. But we have never been averse to it. But I'd say we are discussing. It is under discussion. I couldn't comment whether it's likely to come or not, but it's quite hard in the off-highway world.
Yeah, it is the question for the future, what the future will bring. At this moment, I think we are at a very low level regarding the harmful emissions in the exhaust gases. Is the question if we can go even lower. Sometimes they say that present diesel engines are producing cleaner air than they are sucking. Mm-hmm. So they are something like washing machines for the air. Yeah, but I think the future can bring the competition in the CO2 level or fuel economy. Could be one of the rules for the next emission levels. Why not?
Yeah, of course we're mainly talking about Europe, but do you think there might be something that could happen in North America as they have already implemented something for trucks?
Goes to a political discussion.
Yeah.
So North America, it's stable at the moment. California is looking on further NOx reduction, but not really pushing legislation. They have voluntary programs to it, but they have also incentivized those programs. So, but then that will drive it towards competition again, rather than legislation.
Okay, are there any questions? No. Okay, one thing, we are nearly getting to the end, so a final question I'd like to ask is, we're mainly talking about the existing known technologies, SCI, GR, DPF, that are likely to remain in place for stage 5 and to keep fuel economy at lower levels than previously. Are there any existing technologies that could be in place to improve fuel economy, but that are not currently used due to cost restrictions? Are there, so in other words, are there other things that could be added to the existing machinery to bring fuel economy even better, to make fuel economy even better, but there are cost limitations and other practical limitations to do it? What else is available on the market that is not there?
Well, at the moment, market is full of hybrid cars, and hybrid technologies are also something we can look on the off-highway side. Electric hybrids, or then on the excavators, they also could utilize hydraulic hybrid systems. On ag machinery side, we could electrify our implements and the machinery that we are pulling with the tractor, and reduce the hydraulic loads and hydraulic losses in the system. What else there is? Then looking on the engine side, we can downspeed the engine with connection with the CVT transmission, so we can optimize engine range. Where do we operate the engine? There are a lot of technologies out there. Some of them will need some industry standardization, like for example electrifying implements, because implements need to be fitted for different tractors and they need to fit all the tractors. So we need some more standards on the industry side over there. But there are technologies and they are developing, and I'm sure everybody's looking at them.
Okay, David? I'm
glad you raised the topic of hybrid. You know, we have now in production a hybrid excavator, and that works well because that is a circumstance where, because excavators swing left to right, there's a lot of kinetic energy to be recovered. So in that instance, it can be very favourable, and we see 25 to 50% savings in fuel consumption under various circumstances. If you put the same equipment onto or the same hybrid technology onto a dozer, which is primarily operating at single speed, almost full load, there would be obviously no benefit at all, and you just have to drag this thing around. So it really is a question of applying it in the right places. Now, then, in terms of technologies, I don't want you to just think of technologies in terms of engine technologies or after-treatment technologies. For us, the real area where is to actually look at what is this machine doing, and is there a way we can, for example, by automation of job site or automation of machine, can we do it in a more efficient way? So that again means come away from the engine, come away from the transmission, come away from the machine, and actually look at what the machine is doing. We, for example, have remote operating mining trucks, which are operated in a driverless way, and that changes the optimization problem entirely. And as a consequence, we see fuel savings.
Okay. Similar way, we also have for the field use, automated steering systems that we minimize the overlap between different rows in the crops when you're planting and seeding, and there's a lot of, like said already in the beginning, there's a lot of optimization being done on the operational side.
Yeah, honestly, we are so small. We are quite small to do the basic research. So honestly, I do not know any technology which is not known today, which could be used to decrease the CO2 or fuel consumption. But I would see the potential, for example, in improving the efficiency of another devices which are located in the vehicle. For example, when you imagine the tractor, the engine is source of energy, to which is connected another devices like pumps, generators, and so on. So I could see some potential in improving the efficiency of these pumps, the generators which are connected to the engine.
Yes, yes,
Yep.
such as electrification.
For example.
Yep, yep.
Okay, excellent. And to conclude, I've got a question from the audience that came in by text message. So do you see, we're talking about hybrids, but do you see diesel as the main propellant for all applications? Do you see any battery electric fuel cell on the horizon for non-road mobile machinery?
I think definitely
yeah.
the diesel will stay
Yeah,
number
diesel engine will remain as number one, but is the fuel rate always diesel?
I think the lower in kilowatts you go, the higher the risk is that, in particular, electric becomes important. But no, for large serious machines, it's diesel. It's not gasoline. We can't store gasoline on site. It's not gas. We can't refill gas at machine sites. It's diesel.
It's diesel, but is it petroleum diesel or something else?
Yeah, great. Excellent. I think with this, unless there are any final questions from the audience, there's one over there. So is a microphone coming? Yeah, Alex, if you can please bring. Yeah, just.
Hi, it's Will Missions from Ricardo. So I guess one final question. No one mentioned waste heat recovery to that, in the answer to that last question. I know Dave mentioned it earlier in his comments about the complexity of putting it into off-highway machinery, but do you consider that that's just not a viable solution for the off-highway market anytime in the near future?
Sorry, could you repeat?
Waste heat recovery.
Waste heat recovery.
Yeah.
Do we see it as viable for the future?
The benefits it brings are fairly limited at this moment, and also, like I said, we are running into other heat management issues with that. So we might need some, but does it really bring much benefit? It goes more to the section of fine-tuning then. So the benefit is really small.
Remember what I said at the beginning. Never say never say some technology will not see the light of day. I've been scarred too many times with that. They generally do, but what I would say is that with waste heat recovery, for our circumstances, it is a lot harder. There is one hard and fast rule though, and that's the first and second law of thermodynamics. You're not getting around them.
Okay, great. So I think we can wrap up the session. Thank you very much for joining this panel. I think we had a very interesting discussion on fuel consumption and where the horizon is for non-road mobile machinery. So please help me join them with a round of applause.